Okay, so attention, that's kind of the, when we talk about attention, usually we're thinking about that mental effort, that concentration that is needed to get tasks done. Attention is not a unitary construct. So a lot of people, in my early work, I did a lot of studying in the area of attention, and people would come up and they'd be like, what attention measure should I use? Well, that's a complex question because it really matters like what aspect of attention that you're really trying to assess. And attention doesn't just reside in one area of the brain. In fact, nothing really resides in one area of the brain. We're talking about these interconnected systems. So I'm going to talk to you about a couple of different types of attention today. One is selective attention. So really this is the attention that allows us to kind of select what it is that we want to pay attention to and ignore other information. So right now I'm hoping that you all are selecting to pay attention to me and ignoring whatever else is happening on your computer or in your environment. Some of the ways that we can look at selective attention in the laboratory are to use what we call visual search task. Because when a person does a visual search task, they have to quickly search through information and ignore information that's not relevant. So here's an example of a type of visual search task that we might give in the laboratory. And so we might ask the individuals to go through these lines of numbers and cross out all the sixes as quickly as you can. So they have to selectively find the sixes and disregard the other numbers that aren't important. Now we can increase the complexity by saying, now we want you to cross out all the fours and the sevens. So now they have to look for two numbers rather than just one number and selectively ignore the other numbers. And again, you can see that many of our tests involve multiple processes too, right? So you got to have good visual discrimination, speeded processing is going to come into play here too. But in this sort of test, we look at the amount of time that it actually takes people to complete the task. And you can see as people age, there's an increase in the amount of time that it takes people to do the task. So between the 20s and 85, it almost takes a person 30 seconds more to complete this task. And when you get over to needing to complete 2, you can see that we're talking about 40 to 50 seconds more. So that can mean a big difference if you think about across the whole amount of your day, right? These different activities that you're involved in, that change in the amount of time it takes you to do things is going to increase. And so again, we do see that age-related decrement as people get older. So there are a number of strategies that we can use to lessen those age-related decrements. So contrast or pop-outs are a good example. So let me show you that. So here in this box you're going to see, I want you to tell me which box it's easier to detect that there's a different letter. And I'm going to show you 2 boxes. Okay, so was it easier to find the different letter in the top box or the bottom box? The top. And why is that? Okay, so an O is very different in its contour from the L, and so it almost just pops out at you, right? Because it's so different. And we call this a feature search. It's something that's pre-attentive, it's very automatic, it just kind of pops out and happens because it's so different. Whereas in the bottom, we really had you do a conjunctive search, which is almost like a serial search. You have to look through until you actually identify this T because it's so similar to the L's. And one of the things that I did when my son was younger so that I could see him when he was out there playing and playing soccer is have him wear an orange hat. And it was really easy to identify my son and all those other children. As he got older and you couldn't wear hats anymore when you were playing soccer, it became much more difficult when you're just seeing all these blonde and brown haired boys running around out on the field. So basically I used this principle of a pop out so that I could easily identify where my son was. Okay, another aspect of attention is capacity. So we have this idea that we all have kind of this limited capacity of attention that we can just decide to distribute how we want to. And one of the ways that we can measure that amount of capacity in terms of some of our standard neuropsychological tests is to have people do a task that's called like a digit span task. So we read a number of numbers and then we have the individual repeat those numbers back to us. So I'm going to give you an example of what this might feel like. Just need to get the numbers out here. So I'm going to read you some numbers and then you can write them down if you want or just try to remember them. Okay, 7, 5, 8, 2, 9, 4, 1, 0, 6. Okay, and then we'd have the person say all those numbers right after us. Now, that was a really hard one. Usually we'll start with 2 or 3, and then we'll work up and we'll see how far they can go. And you can see that typically when we think about most people's digit span, we have this number 7 plus or minus 2. And if you didn't chunk the information, because you can try to chunk information, if you chunk, then you can expand the amount of information that you can remember. But if you just take each digit individually, usually a person will remember 7 plus or minus 2 digits. And you can see that our 20 to 24-year-olds were remembering 6.6. That was the highest number forward, their mean. And by the time we're 85 to 89, it's 5.82. Now, we can make this a little bit more difficult. And oftentimes when we're using our attentional capacity, we're just not repeating things, but we're kind of working with information that we're holding online. So one of the things that I could have done is read those same digits to you, but then said, okay, now I want you to reverse them and give them to me in the backwards order. So now not only do you have to hold them online, right, but you have to flip them around. So we call that working memory, kind of this idea of holding information online and working with it. And you can see that for all age groups, that's harder, right? People don't get as many correct in terms of remembering as many. But again, you see that age-related decline that occurs with time. Now, how does that play out, or what are conditions under which we might see more age-related declines than others? So all of the different processes that we do in our everyday life, they really vary on a continuum, from more automatic to more controlled. So how many of you remember learning to drive a car? Any of you remember learning to drive your car? Okay, so when you first got into the car, there were a lot of different things to remember. And if you had a stick shift, that just upped the ante, right? But you know, the first time you're out on the highway, it's a very controlled, you're putting a lot of attention into it sort of process. What's driving a car like for you now? Does it take a lot of your attentional resources? Okay, it's something like, how many of you have found yourself halfway to work and then been like, oh, I was supposed to be going to the store or something, right? Because you're thinking about something else and you're not even paying attention to the mechanics of driving. What happens if all of a sudden you're in a snowstorm? It's no longer automatic, right? It becomes very effortful. You're paying a lot of attention to what you're doing. And so we can say that our tasks that we do vary along this continuum from more automatic. These are things that we don't need to use a lot of our attentional capacity for. They're very easy tasks, they're very familiar to us, and they make it easy for us to complete two things at the same time. So I think another example would be typing or texting, right? Like once you learn to text, that's a very automatic sort of thing now. Controlled processes are those that require a lot of attention. They're used for more difficult tasks, they're used in novel situations, and they're going to be difficult to carry two of those things out simultaneously. So if I had you do something like solve some math problems while you were also completing some sort of verbal tests for me. That might be very, very difficult for you to do. But maybe if I just had you randomly drawing circles while you were solving some math problems, that might be a lot easier for you to do. So the way that we can look at attentional capacity in the laboratory too, or people's ability to kind of simultaneously do two things, is to have them do divided attention task. So you can have a person come into the lab and you can, in this sort of example, they said, okay, for your first task, you're going to see a region on the screen in which a varying number of crosses appear simultaneously. When, what does it say? 4 of these crosses form a square. Please press the key as quickly as possible. So that's one of your tasks. Now your other task is you're going to hear a low tone in sequence, high and low tones in sequence. You have to decide when the same tone occurs twice in a row and press a button quickly. Okay, so you can see that these are actually 2 pretty controlled tasks that you're going to have to do. And when you have to do them both at the same time, they're going to take they're going to use up that attentional capacity that you have that is limited, and so your performance on one or the other is going to suffer. Now, when older adults have to do 2 controlled tasks, that's when we're going to see the greatest decrement in their abilities compared to younger adults. If both the tasks that they're doing are simultaneously easy, they're not going to show as much difference from older adults. Now, one of the things that we hear from our older adults a lot is that they have a lot of difficulty multitasking. And multitasking is something that requires the use of this attentional capacity. It requires use of working memory. And in fact, in a study that we did a while ago, where people were in our smart home and they had to do this very complex day out task that required multitasking, we actually found that our older adults who multitask and were bright, so were highly intelligent, multitasking worked out okay for them. But if you were an older adult who was multitasking and you were not as bright, multitasking actually decreased your performance. And so a lot of times, our older adults, just as part of the way they compensate, is that they stop doing as much multitasking because that multitasking actually can interfere with their performance rather than make them more efficient. Okay, so we talked about some of these changes that occur in attention in terms of capacity and in terms of selectivity. What are some implications of this for technology development then? Okay, so try to find times where you're not going to be interrupting activities that take a lot of concentration, maybe transition points, maybe more automatic tasks, but can you use some of these principles to think about what might be the best time to prompt? Very good point. Okay, so how much information you want to present on a screen, and maybe also like that working memory of how much you want them to have to hold in memory too. So you really want to have that information spelled out for them. Right, so if you're going to decrease the complexity, can you decrease what's on the screen? Can you decrease how many times it's going to take for a person to get there? Or can you make that really clear to help get them through the process somehow? Okay, good. I think the contrast comes out here again too in terms of selective attention, just like it did in terms of visual processing too, right? The more that we can have things that contrast each other, and we use this in rehab too. You know, if you have someone who they have slowed processing speed and you want them to find their hairbrush on a table and their table's brown and their hairbrush is brown, that may take a long time to be able to locate it. You put a pink hairbrush on a brown table, it becomes very easy to get that item. So these are ways that not only in terms of changes in our eyes, but in terms of changes in terms of selective attention, that these sort of contrasts can be helpful. Okay, any questions about that information? All right. I think we did this. So how might we lessen the effects of age-related attentional decrement? Oh, well, let's ask that. We kind of did. But what can we do to lessen some of these age-related decrements for our older adults? So we talked about the contrast. I guess we kind of already talked about it. Okay, I'll let you guys go. We talked about it. All right, we're going to move on to talk about memory and some information processing models. So in terms of some of the early models and the way that we process memory, first we have to attend to the information, right? So how many of you have ever tried to, you just got introduced to someone and then you turn around and you're like, oh, I forgot their name. Now, how many times is it that you forgot their name because you didn't attend to the name in the first place, right? Like that happens. Okay, so if we don't attend to the information, we're not going to get it into our memory and we're not going to be able to remember it. So the first thing you have to do is attend to the information. Then it goes into kind of that limited capacity memory, that working memory or that short-term memory, where unless we're rehearsing the information, we're not going to push it into our longer term memory, which is where we really want to get it, or using some sort of strategy to kind of get it into our longer term memory so that later on we can then retrieve it. And when we retrieve information, we have to bring it back into awareness, into our short term or working memory, so that we can produce that information. So if I asked you to tell me the name of your third grade teacher, anyone able to retrieve that? A few of you are able to retrieve that information. Okay, so you have to go into your long-term memory, right? Use some sort of strategy to kind of locate that information and then pull it out so that you can then actually produce that information. Okay, so much of the research on memory has really dealt with what we call episodic content memory. So when we do a lot of our testing with the older adults, we're testing their ability to remember a list of words or a story that we've just read them. And so these are popular ways that we assess kind of the intactness of a person's memory. And typically, we're going to see just slight changes until around the age of 65 or so, and then we're going to see more rapid changes. So this is from a prose memory test. So we read the person a paragraph, and then we see how much information they're able to recall. And you can see that those under the age 30 and those 60 to 70 are recalling about the same amount of information, about 9 units of information, but that information decreases when one gets to 70 and 80 and then to 80 plus. So one of the biggest questions we've asked is what accounts for these age-related changes, Why is it that older adults are having more difficulty with their memories?